Hello together, my name is Markus Huemer. I'm from Austrian company Next Generation Recycling Machines. Thank you WM, thank you FORPET for giving me the chance to talk about the NGR LSP process, the polycondensation process, which is a crucial factor for the FORPET material and the FORPET packaging solutions. What is the LSP doing? The LSP is a polycondensation system, as you might know from conventional SSP system, but we handle the melt or the polycondensation step in the melt phase. Means we use the extruder to melt the bottle flakes or the PET material and then convey the melts directly in the polycondensation reactor. Means the polycondensation phase happens in the liquid phase. Means the reaction times are much faster, the melt control is easier to handle compared to SSP systems. And we have seen in the FORPET applications that a couple of arguments speak for the LSP. One of them is the IV lift, which happens in minutes compared to SSP systems, and the stability of the viscosity. You can imagine that when you foam such materials, you always want to have quite stable viscosities, because otherwise the foaming might not be that elegant. What the LSP is also doing is the purification, the decontamination from harmful chemicals that could prevent from getting food approvals. So we have FDA, we have EFSA, and we know that decontamination-wise, the purification is very efficient as we are in the liquid phase. And it's also somehow logical that in a liquid state, the decontamination must happen faster and easier. We have a good database already collected on that, and if any questions arise, please let me know later on. I mentioned already that for FORPET, the stable viscosity is key to enable a stable foaming process. We can see here that in the reactor we have also some online measurement tools where we can measure the viscosity in the process and counter-react with the vacuum system. So at the end of the process we have a guaranteed IV range of 0.015 deciliter per gram. And this is, I hope that FORPET confirms this is quite crucial for them to have it as stable as possible. Also with varying input viscosities. The melt reactor can handle also variations on the input stream and still have a very uniform viscosity at the end. Decontamination is another point which is important, of course, for all food packaging applications, not only for bottle but also for sheet, cups and trays. We did many challenge tests with Fraunhofer. We did a lot of tests to get FDA, EFSA, everything is confirmed. The decontamination performance is just best in class, also due to the fact that the liquid melt is easier to treat than compared to granules or flakes. We know that the decontamination performance is excellent and ready for the future as well, because we also see the trend that the flakes, the bales always get more and more contaminated as they are longer in the loop. So the decontamination performance will have or has already a crucial importance, and the importance will only grow, just to prevent from benzene, from BPA, from limonene, from all the contaminants you don't want to have in the food packaging material. Yeah, here on this slide we just show some of the different machine configurations. You can place the LSP even between existing PET recycling lines. You can go directly in a product after the polycondensation process. After the liquid state polycondensation reactor, you have a melt that is upgraded and decontaminated to food grade levels. What you do with the melt is your decision. And we have customers who go inline in sheet. We have customers that go inline in fiber. Strappings we don't have direct yet, but we also have a customer going directly into preforms. We have a development project with a big preform injection molding machine maker, and there we are going inline from flakes to preforms in one step. Energy-wise, very interesting nowadays because you save the extrusion process on the PET preform line. There are different possibilities on the input material. Maybe you know we have, or IKEA has some shares at NGR with the main target to go deeper in the fiber-to-fiber recycling industry. When bottle flakes will be used in the main markets for the bottle recycling, where shall all our clothes come from if the bottle flakes are used for the bottle recycling? So there is a deep investigation to go from used fibers back to fiber-grade granules. And thereby you can imagine that different machine configurations will be necessary. So a lot is possible. The liquid melt is quite flexible, and as mentioned already, it's customer decision what to use the melt for. The LSP technology at NGR is available since 2013. We started at the beginning with fiber to fiber. Nowadays, of course, the bottle-to-bottle recycling is of main interest for us because it's also our main interest on the market. Nowadays, we have like 53, 54 systems sold, 35 of them approximately in operation already all over the world in many different industries, bottle-to-bottle, bottle flakes to special applications, bottle to sheet directly, bottle to whatever, fiber to granules. So a lot is possible, and we see that the trend is going forward. We see also from competition that the liquid state is a topic also for them. So from my point of view, it was right to go in the liquid phase when NGR did it a couple of years ago. Yeah, that's why I called it the PET recycling world is going liquid. You can check that out in Hall 9. You will see a couple of them. Yeah, thanks for the possibility to talk. Thanks FORPET, thanks WM. Will be a great cooperation and looking forward to the future.